So what if I told you that the key to saving one of the world's most important crops wasn't in some high-tech billion-dollar lab, but right here in your pocket? Yeah, today we're going to dive into how simple yet incredibly powerful AI is becoming a frontline defense for agriculture all over the world.
Okay, just take a look at this. On the left, you've got a healthy tomato leaf, vibrant, green, full of life. But on the right, well, that's just devastation. We're talking about diseases like leaf blight, leaf curl, verticillium wilt. These are constant, silent threats for farmers everywhere. They can literally wipe out an entire harvest.
So just how big of a threat are we really talking about? Well, this one number, it says it all. 50%. That's the potential yield loss for tomato farmers across the globe every single year because of these diseases. I mean, just imagine, half of all your work, your investment, your income, poof, gone.
Right, so let's get into it. This is what we're calling the 50% problem. And as you can imagine, the stakes are unbelievably high, and the old ways of fighting back, they're just not cutting it anymore.
And look, we're not just talking about a few plants in a backyard garden here. This is a global industry worth almost $87 billion. So when half of that is at risk, year after year, you're looking at a huge crisis, not just for the global economy, but for food security too.
So you might be asking, why can't we just handle this the old-fashioned way? Well, the thing is, traditional methods, having experts literally walk the fields and inspect leaves one by one, it's just incredibly slow and labor-intensive. Plus, it's prone to human error, it doesn't really work for massive farms, and forget about it in remote areas where you can't just call up an expert.
So if the old way isn't working, what's the alternative?
Well, this is where technology steps in. The goal, really, is to create a digital, world-class plant disease expert, one that anyone, anywhere, can carry around in their pocket. But how on earth do you teach a computer to see a disease? It's actually a pretty logical four-step process. First, you've got to collect a ton of data. In this case, thousands of pictures of tomato leaves from farms in Ghana. Then you augment that data set, which is a fancy way of saying you create even more images by flipping, rotating, and scaling the originals. Step 3, you design the AI's brain. It's a special kind called a convolutional neural network, or CNN. And finally, the fun part, you train it. You just show it the images over and over and over again until it gets really, really good at spotting the differences. You can basically think of this as the AI's textbook. To get it up to speed, researchers fed it a huge data set. We're talking almost 17,000 images, all neatly sorted into 5 groups: healthy leaves, and then 4 different diseases. This is the raw visual information the AI uses to learn everything it knows. But here's the thing, not all AI brains are created equal. So the researchers didn't just build one. Nope, they built several different models and basically had them compete against each other, like a bake-off, to see which one was the absolute best for the specific job. And this table shows the results of that competition perfectly. You can see the different models, like EfficientNet and MobileNet. Now, look at their training accuracy. That's how well they learned their stuff. Then, look at the model size. You start to see a pattern, right? A really critical trade-off. Getting that super high accuracy often means you're dealing with a much, much bigger file size. So, this gets us to the core dilemma: accuracy versus efficiency. On one hand, you've got a heavyweight champion like EfficientNet. It's 97% accurate, which is amazing, but it's a big file, and sometimes it can overfit, which means it's like a student who just memorizes the textbook instead of actually learning the concepts. On the other hand, you have a sprinter like this custom model. It's a little less accurate, sure, at 87%, but it is tiny and super fast. So, if you're a farmer in a field with no internet, which one do you think is actually going to be more useful? And that question brings us right to the real genius of this whole project. How do you take one of these powerful, complex AI brains and, well, put it on a diet? How do you make it lean and mean enough to fit onto a simple device? The answer is this really cool concept called Edge AI. See, instead of a farmer taking a photo and sending it up to some powerful computer in the cloud for analysis, Edge AI runs the entire model directly on the device itself, right there on the phone. What does that mean? You get instant results, it's totally private, and, this is the big one, you don't need any internet at all. So how do they actually shrink the AI? Well, think about it like this. It's kind of like taking a huge, high-resolution image file and compressing it down into a tiny, fast-loading MP3. You still get the song, right?
They use these clever techniques. One is called quantization, that basically simplifies the AI's internal math, making it way smaller and faster without losing the core of what makes it so good at spotting diseases. And this workflow here, this shows you exactly how that happens. So the models are first built in a framework like TensorFlow, but then they're passed over to a platform called Edge Impulse. You can think of Edge Impulse as the specialist that does all the heavy lifting. It optimizes, compresses, and packages the AI, getting it ready to be deployed on a real-world device out in the field.
Okay, so that's all the theory, but how does it actually work in practice? Let's go from the lab out into the field, because this is where all that amazing tech becomes a real, practical, and honestly, a life-saving tool. And you won't believe how easy it is to get this tool into a farmer's hands. They just scan a QR code with their phone. That's it. Seriously. The entire AI model just loads up, ready to go. No app store, no complicated installation, just scan and diagnose. And here it is in action, working in real time. A farmer sees a suspicious-looking leaf, points their phone's camera at it, and boom, instant diagnosis. Healthy. Leaf blight. Fertilicium wilt. It is literally like having a world-class agricultural expert standing right there with you in the palm of your hand. But this is so much more than just a cool identification app. It's part of a much bigger system. In Ghana, where this was developed, a diagnosis made on a farmer's phone is automatically sent to a national portal. This instantly connects the farmer with the country's plant protection directorate. So a single photo can trigger a coordinated national response to stop an outbreak before it even has a chance to spread. When you step back, you realize this technology is about so much more than just tomatoes, right? It's a blueprint, a roadmap for how we can make powerful AIs small, efficient, and accessible to everyone. It's about putting these incredible tools into the hands of the people who are on the front lines of some of our biggest global challenges. And that really makes you wonder, what other massive problems could we start solving with an expert AI that fits right in our pocket?